Hello everyone. Today we're going to show you a demo using Microsoft Fabric to unify the data sitting in different solutions. Specifically, we have data sitting in Azure SQL DB and some flat data sitting or residing in Azure Blob Storage. We will be using some of the features in Microsoft Fabric to ingest these data into a Fabric Lakehouse. Then we will be using the notebooks to facilitate the transformation of this data. So let's head over to Azure just to see how the data looks like. So this is my blob storage account in Azure. I have a raw container containing folders where each of them has a CSV file. I want to combine this with my SQL database. In Azure, I have the SQL database. Let's just query the data to see what it looks like. So it's a regular AdventureWorks database. Let's head over to Microsoft Fabric. The first thing we want to do is to make a workspace that we can use to collaborate and join these data. Now the workspace has been created. Let's make a mirror. So if I type mirror here, then we can choose this Azure SQL database for mirroring. This service will replicate the data we have on the Azure SQL DB. So let's click on Azure SQL database. Then we will put in the server details and the database details. And because I've done this before, then it recognizes this as an existing connection. But let's make a new one for the sake of this demo. Then we want to use my credentials to log in or to authenticate. It will then, as you see, recognize this is an existing connection, so it will reuse that. We can then select all the tables or which of the tables we want to replicate. Let's select everything but these two. You will see a warning if there's something that is not supported, like this column, then it will not replicate the column, but the rest of the table. That's the file name, create. Now we're seeing some of the data being replicated to Fabric. Then we should be able to see some of it, query that data as if it was a regular database by going here and choosing the SQL endpoint. Let's click on refresh. We see the sales LT schema. And we see some of the tables here. Excellent. Good. Let's see if we can query this data using a SQL notebook. So we go back to the workspace, click on new item, notebook. So for this notebook, let's try to query the mirror. Let's put in a query and expand it to see what's inside. You can also just load it to Spark and then it will write something similar to this query. In here, I've just specified a where statement so I can specifically see if this row exists. It was about 6 seconds to retrieve a cluster from the region. And after 30 seconds, we are able to see a row here on, I think it's F8 capacity. Good. So before we make any transformation, we would like to have a lakehouse where we can persist some of the data we're doing. So let's go back to the workspace. new item, Lakehouse. And let's give it a good name. Now we have a lake house. In this lake house, we have this DBO schema. So let's make some more schemas. So in my existing notebook, let's make a new cell. Let's write these SQL statements towards. Oh, yeah, of course we need to select the lake house. Yes, yes, yes. Can we execute it now? Good. So it has now executed. Let's just verify. In tables, refresh. Yes, now I have the schemas. So I can start persisting my data in the different schema. So let's go back to the lakehouse so we can actually make a shortcut towards the data we have in our blob storage. So in my lakehouse, just refresh this one so I have the schemas. New table shortcut. It's in a blob storage. Gonna make a new connection here. Then we need to provide the name of the storage account. Here you are. Again, recognize it as something that exists already. Use my credentials to log in or to authenticate. It already exists. Okay. Then we just use an existing one. So these are the folders we saw in my blob storage. So I will shortcut this folder and it will recognize all the CSV files in it. Then I can determine how to interpret the CSV file. It's comma separated. I can change the name if I want to for the coming table, and let's go. So basically now it's making a shortcut transformation of this CSV file, transforming it into a delta table and making it available in my bronze layer, bronze schema in my lakehouse. Whenever I then add more CSV files into the folder, the shortcut will automatically recognize these files and start the shortcut transformation and add that towards the delta table that will show up in this schema. So now it has been finished. Let's just refresh, and then you see it. You'll be able to query it just like a regular table. So let's go back to our notebook. So if I just refresh this one also, then I see the weather table in my lakehouse. Now I should be able to combine or join these two different, this table with some of the tables in my mirror as well. So this is the weather table that was a CSV file previously, and this is my mirrored tables from the mirror. Great. So this is the result set of the join. Let's save this output as a new data frame or new table. Now we're saving it in the DBO schema. And we should now be able to see that, of course, right here in my DBO schema. So this is a quick way of sourcing in data from different places and exposing it in Microsoft Fabric. Then let's try to make a materialized lake view. This is a feature that simplifies making a medallion architecture. So let's try to see that in action. Right now it's still in a preview state. That means it has some certain limitations to it, and one of them is it doesn't work with mirror tables. But one way to get around it is to shortcut these mirror tables into the lakehouse. So if we go back to the lakehouse, then we can shortcut, saying it's residing in Microsoft OneLake. Here is the mirror. We will choose the tables that we're interested in. It could be all of them, but let's just pick some of them. Go. So this is also a way to scope what should be available in your lakehouses. Let's go back to the notebook and let's make a materialized lake view. So this is the code to make a materialized lake view. It looks very similar to a regular view. The only difference is the constraint part. In here, we can add constraints to ensure rows meet a certain data quality level. Here we have defined that the first name must always have a length of longer than 3 characters. If it's not, it's going to be filtered out and not included in this materialized lake view. We can also define a constraint that fills the flow totally. In here, I have defined, for example, first name and last name. Right now, we have done the opposite, so it's not failing, but you can certainly do that. You can apply the transformation as you used to. Here, I'm just defining a join, and now the table has been made. If I query the source table, then I should be able to find a row where the first name is equal to Bo, but a similar query towards our materialized lake view should not show this row because because of the constraint we define. Bo is shorter than 2 characters or shorter than 3 characters, and those should not be shown. And this works as expected. For the sake of this demo, I'm going to make one more table in the gold layer where I'm going to source it from the materialized lake view we just did, so I can show you the lineage feature for the materialized lake view. If we go back to the lake house, click on this button, then you will be able to see a lineage view of how they are dependent on each other. You will be able to see if you just click on run, and this is different from traditional materialized views. That is, these does not update immediately when the underlying data sources are changed. These are scheduled just like regular pipelines. And this has both pros and cons. The pros is, of course, it fits really well with existing data pipelines, where we also put a schedule instead of relying on an event-based architecture. The interesting thing about the materialized lake view is this optimal refresh, where it determines by itself whether a full refresh makes sense instead of an incremental load. So if we click on this one, then we can see the history of the executions. So this one was the one I just clicked on. Then we can see details of the execution. For example, on the silver layer, we can see the duration it took. We can now see whether something has failed or is in progress. In this flow, you would also be able to see which flows have been failed, either by the constraints or by other errors. And if we had more runs, then they would be listed here. So you can always go back and backtrack how the executions have been running. You can also schedule it to run on a daily basis or every night. And then you can go into the data quality report and see how many rows have been dropped because of the constraints defined in the materialized lake views. You can deep dive into the view and see particular which constraints have been enforced and how many times over time. So this wraps up how to unify your data using Microsoft Fabric and how to use the Materialized Lake View to implement the Medallion architecture. Thank you for listening in. I hope this was interesting, and I see you next time.